What's up guys, Riley here back with another video, and today I'm going to be addressing one of the questions I got in my last video, and that video was how to simulate sports seasons in Excel. Today we're going to be talking about how to simulate division win probability in Excel. And it's going to be along the same lines as last videos. We're going to be taking a look at a full season schedule and then simulating each game from that season schedule, all that stuff, with a little bit of a twist at the end to derive that division win probability. So basically the question that I'm going to pose pre-video is, taking into account simple NFL team ratings and a full season schedule, how can we use those two things to derive the Houston Texans, for example, season or division win probability at this point in the season, so midway through the season? How can we derive that using just, like I said, simple NFL stats for the ratings, and then also a full season schedule? So I'm going to show you exactly how to do that today, and hopefully by the end of the video, you guys will know exactly how to do that yourselves. So first off, like I said, you're going to need some ratings. And of course, ratings are generally going to be, or variables in general, are going to be the most important part of a simulation because they are going to determine the output. Now, the ratings I've used are very simple, and this taking into account this as well, that don't take these ratings, or sorry, the output rather of this simulation as truth, because these ratings I'm using are very, very simple and aren't going to be that predictive. So the most important part, I think, pre-model to consider is find ratings and variables that are predictive. So the ratings I've used, like I said, very simple, but pass offense, pass defense, and rush defense. These numbers literally represent the amount of points that are projected to be scored in each sector. So, for example, pass offense, Texans are basically, this 15.4 means that the Texans are projected to score 15.4 points on average from their pass offense. Then rush offense, likewise. Pass defense, that's basically how many points they're projected to allow through the air from the opposition, and then rush defense, likewise, but on the ground. So that's how you derive. That's how I've derived these ratings to predict our, eventually go on to predict our games. And this overall rating, which will be used, is basically just a net of total offense on average, or total offensive points per game minus total defensive points per game, or defensive points rather allowed per game. And that's going to be for the Texans a 1.3 overall. Now that we've got our ratings, though, we can now move on to the schedule, and this is going to be a similar setup to the NBA, which is what I used for the last video on season how to simulate a full season in Excel. So we're going to need a full season schedule, but obviously for the NFL, we're 11 weeks in now, so there's still a few weeks to go. So what we need to do is predict and basically simulate the rest of the games. So how I've gone about doing that is by using these ratings, of course. And this formula looks pretty bulky, but it's just kind of the way I've gone about doing it. Of course, there are other even simpler ways to go about predicting games like this. But what I'm basically doing with this formula, I'm not going to go into it in full because that's not really the point of this video. But basically, all I'm doing is taking the Texans' points, or basically passing offense points, and adjusting it for the Colts passing defense, and then likewise with rush offense and the Colts' rush defense. And then, so that's going to serve as the mean in my norm inverse. Now, if you're not familiar with norm inverse, I would highly recommend going back to one of my old two videos and watching either one or two or both of those if necessary, because I do go a little bit more in depth into what norm inverse is, but it's basically going to return the cumulative normal distribution of the mean based on the probability of a random number between 0 and 1. So that rand, which is literally, like I said, returning a random number between 0 and 1, is going to be, so it's going to serve as the probability for this norm inverse function. And based on how high or low that number is, that's going to be how high or low this points total is. And that's how we get simulations from. Now, I also am going to wrap that in a round because I want a whole number. Obviously, in the NFL, you can't score 13.33 points, so I would want to round that down to 13. So I've also stuck in a round, and then also on the very outside, I've also stuck in a max because there is potential for this that norm inverse function to return a negative number. So in that case, obviously, you can't score negative points in the NFL either. So we just want to round that number up to 0. So that's what that formula is doing. And it's the same formula for both teams. Obviously, just the Colts, it'll be taking their pass offense and not the Texans' pass offense. And likewise for the rest of the ratings. And then also we need to determine wins too, whether this is a win or a loss for which team. So I've separated each team by home and away. And then simply I'm identifying whether in this simulation, whether it's a home win, a home or an away win, or a tie, and that's all that is. So that's how to go about simulating the games one time. So this represents one simulation of the games. Now we need to add up all these wins to then go ahead and determine whether each team has won their division or not. So let's go ahead and take a look at the stats page again here. As you can see, sim win, sim loss, and sim tie. This represents one simulated season, totals of all the wins, losses, and ties. Now, the next thing to address is going to be a tiebreaker, because the same or two teams cannot win a division, obviously. So we need a tiebreaker if the top two teams are tied for total wins. And for me, I'm using a very simple one that's not the actual NFL tiebreaker, which further backs up my point that don't take these results as truth or fact, because obviously once again, my ratings are very simple, but also the tiebreaker I'm using is not the actual tiebreaker used in the NFL. My tiebreaker is literally saying if the top two teams are tied in wins, then basically the team with the highest overall rating wins the division. Obviously, that's not how it works in the NFL. The NFL is based on more intricate stuff like head-to-head, which you can incorporate into a tiebreaker if you want, but it would just take a much more lengthy formula, and that's not really the point of this video. The point of this video is to basically show you the process behind the output, not get an extremely accurate output. That the output for me doesn't matter as much as the process here. So that's what that tiebreaker is for. And the next, we basically just need to say, did the team win the division or not? We need to identify which team in each conference or in each division actually won the division in that simulation. So the formula I've used for this, and actually you'll now recognize the max function, which is pretty important and can be utilized in a lot of things like this. But what I'm basically saying is, in the array K2 through K5, which is the AFC South, is the max of that array, the max of that tiebreaker of the array, equal to the tiebreaker of the given team that we're on right now. So if the max of that array is equal to the Texans' tiebreaker number, then that means the Texans have won their division because they have the highest tiebreaker in that division. So that's the logic behind that, and that's basically what that formula is saying right there. And what you can do as well is, if you code this formula correctly too, where basically what you need to do is make that array the same for the four teams in the first division. And you also need to make sure that the row number is not static. And what you can do is copy and paste this down to the next division. And because of the fact that it's not static, it'll move that row down 4. And in turn, it keeps that array the same for the next 4 teams. So because, for example, let's say, looking at the Texans here, their array is K2 through K5. We're moving that array down 4 to the Ravens, and also their own tiebreaker is K2. We're moving that down 4 to the Ravens as well, so it's K6. But it actually stays the same for all 4 teams in that next division because you've kept that array static for the other 4 teams. But you don't, as long as you keep that row number non-static. Anyway, so that's just a little tidbit of information. Another little tidbit of information, rather, too, that I wanted to point out is how to get this division if it's not identified for you. So what I've basically done, that's the simulations. What I've basically done is identified AFC and East, and then this little thing here concatenates it. Now, if you're not familiar with concatenation, it's basically just combining 2 cells plus any string you want. So for me, I'm basically combining AFC and then a space and then C2, which is equal to the division, so East. So it returns that AFC East. That's how I do that. And then I just got the index match it, which I've talked about in the index matches a ton. They are very important in Excel, or VLOOKUPs, very similar idea. But index matching that to match, so we just match the team and then it returns the index of their division, and that's how we get that division. So now that we've got the ratings figured out, we've got the game simulated in the schedule, and we've also now been able to identify who's actually going to win or who's winning the division in each simulation for each division. Now we can simulate that division number and get the actual probability of each team winning their division. So that's all we're doing in this one. So all we're going to do is simulate this number right here. So I've actually gone ahead and done the simulations already because it does take a decent amount of time to simulate this whole thing, because it is 32 teams times 10,000 simulations. So it does take a decent amount of time to do, but what we're going to basically do is to first get this number into the simulations page, we do another index match. First, we're indexing that whether the team won the division or not, so that 0 or 1. If the team wins the division, obviously it's going to return a 1. If not, it returns a 0. And we do that for each team. And because that norm inverse is determining the game results, and then thus those game results are determining who won the division, we can actually simulate that division win or not won number, that 0 or 1, 10,000 times, and then all we do, so just to remind you, by the way, I've already simulated them, but I'll show you how to set up a simulation. So once you get that number in here, all you have to do is select the entire array from your upper value, your upper left value here, which is that first index for the Houston Texans, all the way down to the last index for what will be the Seattle Seahawks, based on the division sort that I've done. And then you're going to go down to row 10,004 in this case, but 10,000 rows down, or however many you want. For me, I tend to use 10,000. You're going to go to data, and this is just a reminder because, of course, a lot of you guys I'm sure will know based on my previous videos how to do this. You select data table, and then all you have to do is input B2, or I'll use like B2 or B3 as your column input cell, and then you just let it run. Don't press anything. Just let it ride, and eventually it'll return all these simulations for this data table here. And what you can do, all you have to do to derive the numbers you're looking for from this, in this case anyways, is just use an average. Just average down the entire column, and that's going to return the probability of each team winning their division. And in this case, we can see here the Texans are 25.3%. And looking back at the stats here, we're going to find that exact same number. Actually, we'll probably run through again, so maybe not that exact same number. But let's see. Just got to unhide a column here. And here we go. So 25.5% now in this iteration of the 10,000. But that is how you get to that number. And like I said, you can start with basic NFL stats, a basic NFL schedule, simulate the rest of the games for the season, accumulate all the wins, the win totals, the loss totals, come up with a tiebreaker, and then all you do is identify who won the division. And as long as you're using that norm inverse function on the scores for each game, you can simulate that division number, whether they won or not. You simulate that number 10,000 times, take the average of it, and that's going to be your number that you're looking for, which is the percent in probability of each team winning the division based on your ratings and the schedule. So that's how it works. Hopefully that makes sense to you guys, or hopefully you've learned a little something new from this, because I know it's obviously sort of similar to my last video, which is how to simulate full seasons. But taking a look at these numbers too, pretty interesting based on my ratings. Of course, like I said, the ratings are going to be, they're going to heavily skew the results. Texans on 25.4%. Colts are favorites in that division at 67.3%, and Titans are slim third favorites there at 6.8%. And then moving down, you have a few locks as well, according to these ratings anyways, with the Ravens at 100%, Patriots at 100%, and then moving down the list too, we actually have the Saints at 98.7%, but surprisingly, the 49ers, based on these ratings in this simulation here, 98.5% to win their division, despite only being one game above the Seahawks, and also coming up against the Packers next week. And this kind of shows how much ratings can skew your results here, because the 49ers net rating for points is 14. The Packers is only a 4.5. So this game was actually rated as a 10-point favorite in favor of the 49ers as well, or around 10 points. So that kind of just goes to show how important the ratings are, because obviously in real life I think the 49ers are -3 or -3.5. But anyways, basically that's not necessarily the best of lines to return, obviously, but not showing that the ratings aren't maybe the most predictive, because of course we're only taking into account basically average points for and against, which is split up by pass and rush to give it a little bit more detail. But that's all we're doing. So very simple ratings, maybe not the most predictive, but at the same time, like I said, the process has been shown. If you have more predictive ratings for NFL, perfect, or any league for that matter, perfect, because then you can apply this method here to get that division percentage, or probability to win the division. So pretty interesting stuff, I think. Next video I do want to go in depth into how to simulate a player's stats for a season. I think that would be pretty interesting as well, and potentially even make a list where all you have to do is select a player from the list, and that would return their their projected stats for the season, so something else to consider as well. That could be pretty interesting. But other than that, if you guys have any other suggestions, please feel free to leave comments below, because as you can see, shown by this video, I do take your suggestions and questions into account, and will definitely consider making videos on them, especially something like this where it's not too hard to do, but maybe you just haven't quite gotten to the point where you can derive that number yet. So it's definitely something that can be very useful, especially in if you're looking at season totals for sports betting, or simply if you want to do it for fun. Yeah, definitely consider going this route and simulating stuff yourself rather than just looking at like 538 and cheating. But obviously, to be fair, 538 does have some very good data on them, so definitely, I always take a look at their stuff anyways. But it is pretty cool to do it by yourself, though, to be fair, and that's what I love doing too. So like I said, hopefully you guys enjoyed this video. I will be back soon with another one, and like I said, definitely leave feedback and comments and questions, and I will look to answer them and potentially make videos off them as well. So like I said, hopefully you guys enjoyed, and I will see you guys later.